G'day guys, welcome back to the workshop. Today's a bit of a different video. I will be showing the process of how I started to, well, actually finished grinding this blade for the birthday blade, but this is also a lesson in not polishing turds, basically. So, as we did in the former episode, we forged this blade, well, we curved this blade and then heat treated it, so it is fully hardened, and given that it's a combat blade, I'm doing a full width fuller, so I want thick edges on both the spine and the edge to prevent injury to my opponents, but also I want, you know, that width of the blade for more of the aesthetic purposes of keeping it in line with the more historical representation of a saber. And so I'm using a 2-inch contact wheel, and this is a 36 grit belt, VSM from Nordic Edge, to grind in this fuller. Now, unfortunately, this video does end in disaster. Anyone who follows me on Instagram already knows, but there was a mistake when I was cutting out the blank for this from the sheet of ADCR V2 with my plasma cutter, and I slipped a little bit and ended up causing a notch in the blade. And I thought I could grind it out, and I ground and ground and ground, but would make it too thin in that area, and it would then cause a weak point in the blade anyway. And I kind of knew that it was going to happen like halfway through the fuller grinding, but I decided to finish it out anyway, half hoping that it wasn't going to be as bad as I thought it was going to be, and half because, you know, I wanted to see what it was going to be like when it was finished. So with the fullers all ground in, I switched to a 60 grit belt to take out the 36 grit scratches, and I do all of the fullering before I do any of the tapering of the blade, because the blade still needs to be tapered in order to flex properly. But I find that doing fullers in both sharp and blunt blades to be better to be done before beveling or tapering. I apologize for the noise in the background. That is a washing machine. It's got really bad timing. But yeah, once we've done the 60 grit, we also go to the 120. I do come back to the 120 after I've done the beveling, because I slipped a couple of times on the 8-inch contact wheel. But yeah, this is my 120 grit, and you can see that switching out the arms to go to my 8-inch contact wheel is actually pretty easy on the fire ant. Figured I'd show how quick it can be if you know what you're doing. And this is the advantage of having a locking tension arm rather than a tension arm that is constantly under spring compression, because you don't have to hold it down. You can use both hands to change fittings. So with the tapering that I'm doing, I ended up using a 36 grit belt to start tapering it out, and you'll notice that I focus a lot of time on the tip, because the tip is still full width, it hasn't got a fuller on it, whereas the fullered section, the only parts that are contacting it are the edge and spine, and so it will remove material from that much faster than it will across the whole length of the tip. So I do a couple of passes on the tip, and then I do a whole length pass. And this will mean that I have a nice solid taper, like an actual straight taper, from just behind the tip, because obviously I want to leave the tip thick for when I'm thrusting in combat, all the way down to the hilt, or the cross guard, or, you know, whatever guard you're going to have. If you've got a fullered blade, especially for combat blunts, that's incredibly important, because you don't want to step behind the, tip, because that will actually cause, again, another weak point in the blade. And so once we'd done most of the tapering, I then went back to the 120 grit belt to finish out the fuller, and also deepen it a little towards the tip, because I realized that I hadn't quite deepened it enough towards the tip. And you'll notice I'm working in sections, and that's the easiest way I've found to work fullers. If you try and do it all at once, you're going to end up failing. And hopefully you can see how thin it got in the center of the fuller there, because it's actually starting to heat color as I grind. And that's not a bad thing. That's just, you know, you don't want to blow through to the other side, so you got to be careful. But yeah, just truing up the ends of the fullers. You could have a run out fuller where it has that kind of rounded run out, but I decided with square. And it's not obvious in these images where you can see the notch, but I will show you in a bit. Back to the 8-inch contact wheel to do the 120 grit sanding pass. Actually, I think this is 60 grit to finalize the geometry, and then I'll go to 120 to start polishing it out. And I basically finish at 120 before I go to Scotch-Brite, because this is a combat blade. It's gonna get beaten up. There's no point in having a high polish on a combat blade, because, yeah, after a couple of bouts, it's gonna end up with dings and scratches, and they almost invariably end up covered in rust. So, what could I have done to avoid the mistake that is coming up? I could have just thrown that bar away and, you know, like, left it for forging blades later, rather than chasing, you know, something that was completely impossible to fix. But instead I decided to bullheadedly follow my follow the mistakes with more mistakes. So yeah, like, basically sometimes there are just times where you're gonna have to chuck a bar or chuck a project when you notice that it's going sideways, without being, you know, stubborn about it. And unfortunately, for this case, it was just purely I didn't feel like I wanted to waste the time of making another blade. I'm under the time crunch of, you know, not having as much time in the workshop as I used to, and also I'm just stubborn. So here's the finished blade, all Scotch-Brited up, nice and smooth, and you can start to see on the spine, about 8 inches behind the tip, is where that notch is. And it's very small, like, and it's round bottomed, and it's not a huge notch, but you can see it there. There are actually 2 cutouts there. And as I do with all my blades, I flex test them, but I knew this was going to break. So I flex tested it a couple of times, and there it goes. The bonus was I got to check the grain, and the grain was absolutely perfect. You can see where the notch was, but yeah, the grain came out amazing, and I am very happy with how the heat treat came out. In the next images, I'll actually show you the test bending I did of the rest pieces. But you can see there's the other little slip from the plasma cutter. It does not take much to cause a stress riser in a sword blade, even with perfect grain. And so here, as we do the flex test, I'm basically just making sure that the actual heat treat was pretty good, and it bends all the way to 90 degrees, no problem, absolutely fantastic. It does take a little bit of a set, but that's perfect. That's exactly what we want. No steel would be able to, you know, stand up to that. And I do a bunch more flexes until I break it. I'd really like to thank my patrons for continuing to support my channel and allow me to continue making awesome stuff like this. If you want to join the Patreon crew, there's a link down in the description below. I also have links to my Etsy store and my Amazon wishlist and all kinds of other fun stuff if you want to check that out. But with that being said, I will be making another blade and continuing this project. So if you want to see more from me, make sure to hit that subscribe button. Make sure to hit the notification bell icon to be notified when I upload new videos. And if you liked the video, make sure to hit that like button. With that being said, I hope you have a fantastic week. See you next time.